What's up, guys? I'm back, and today I've decided it's time for another episode of computer science. Wow. On paper. Today we're going to be talking about linked lists, which I think is a topic that sometimes throws people for a loop. We're going to get into that a little bit about why we use them and how to declare them in C++. So, let's get started. If you are watching this video about linked lists, you're probably already familiar with the concept of an array, which is a sequential set of memory locations that can be used to store a bunch of information. The problem with arrays is you have to know how much information you're going to store, because since it has to be taken up sequentially in computer memory, we can't go and add on to the end of an array if we figure out that we're going to be storing more information than we thought. You can get around that by declaring a really large array, but that is a waste of memory space, and the best way to get around it is to use a linked list. So, what is a linked list? To declare a linked list, we create a struct. And it can be, well, let's say we're going to create a struct about students, so we'll call it a student. And then within that struct, what this is it's a list node. Each struct is a node within a list. This is like a template for what each node is going to look like. And basically within our struct we are going to have the information we want to store. So let's just keep it simple and say we're going to do a student ID. And then within our struct we're going to create a pointer, and it's going to be of type a student, a pointer to its own struct type, which this is the link to the next item in our list. I like to call them next. I'm a fan of next because it makes sense. So basically what we've done, as opposed to creating an entire array of sequential cells, we've created a single object, or we will once we declare it, but we're ready to declare a single object that I'm going to call a node, and it has this next here, which you can see right there. It has this next, which what we want it to do is point to the top, or point to the next item in the list, and that's going to have a link as well. So to I know this is a little bit confusing right now, so I'm going to try to demonstrate how in code to declare a linked list, and then I'm also going to create little graphics like these to show how it works. So within a list we want to keep track of a couple things. We have all these nodes. We want to know which one's the first node, which one's the last node. And that'll give us the information we need to read every other node in between. So whenever we're declaring a list, which remember these are structs with pointers pointing to the next item in the list, we generally want the last node to always make sure that it's set to null. Okay? And we want the first node to be stored. We always want to store node 1 in memory somewhere, because if we can access node 1, we can access the next item within node 1, which will point to node 2. And then of course if we can access node 2, we can access next, so on down the line, and we just need to know when to stop reading list items, because we'll get to when next equals null. So to show how we declare a list, like I said, we're going to want to keep track of the first node. So let's create a pointer called, what did we go with, a student. It's going to be a pointer, first node. So we always create a pointer that keeps track of the very first node. And then we're going to also have one that's going to be used to create new nodes. We'll just call it new node. I have no idea why this thing is changing colors. It's changing color for me. Maybe it will for you. Okay? And then what we're going to do is dynamically create a new node. Now, however you want to get to this point is up to you, but you have some items you need to store. You've gotten to this point where you decided it's time to start storing items, so I'm not going to work through all of that. But let's get to the point where we're actually going to create our first node. What we're going to do is say, let's see, nope, don't auto sync there, don't need that. We're going to go ahead and say a new node equals new. I'm a big fan of putting no throw here. that's up to you. So, what we've done is we've created the first node in our list. Node 1 now exists. But we have a couple things we want to take care of. We want to make sure that we're tracking that we have a new first node. And so we're going to say first node equals our new node. So now, not only do we have a new node, since this is going to be reused over and over again, first node is pointing to the first node in our list. No, you want that. Now, I have to say I drew this kind of backwards because when we add a new node, it's going to end up over here. Sorry, getting a little crazy with the order in which I'm presenting this. Sorry about that. And this will become node 1, just for illustration purposes. But anyway, we'll get to that. So now we have a new node. We want to make sure that if this is our first node, that we are pointing next to nothing, because eventually we're going to put a new node, before it, and we always want to make sure the last node in our list points to null. So how do we do that? Well, before we run this code, we want to set first node equal to null, because in the beginning there is no first node. So I'm going to go back up here on the top and add first node equals null. And then before or immediately after running this code, what we'll want to do is reference the new node, function next, or I guess it's not function, and we're going to set that equal to whatever our first node was. Now if we think about what that means, if first node is null, meaning there's no items in the list yet, then this code will run through. Now we're going to want this to be in braces somehow, however you're doing that, whatever control structure you're using. The first time this runs through, first node is set to null. So what this does is we're creating our first node and we're automatically setting that next to null. And then we go back and point first node. Instead of pointing to null, now it points here. Okay, so next points to null, first node points to our new node. What we want to do is, every time this runs through, allowing this to happen. New node next equals first node. So let's say this runs through a second time. First node is currently pointing here, so when we create another node, next is going to be set to first node and it's going to point in the same location. And then we tell first node to point to the new node, which after we run it again will be right here. And so we just keep doing this, we keep running through this. You create a new node, which is a new student, and it dynamically creates a new node. We set our next member equal to whatever first node is currently holding. So anytime we step back and create a new node, then first node was holding the previous first node, we point to that, and then we set first node equal to this new one, so now it's pointing to the new one we've created. I really should have done this right to left instead of this direction. It kind of messed me up, but I think we're getting the point. The point I do want to make is about this operator here, in case that confused you. In C++, that is a reference operator. It references the member. I don't really know what it's called within a struct, but it references the next, as opposed to just calling it directly. Since we're using a pointer, we have to actually reference it before we can use it. So it's basically the same thing as saying a student dot next, but throwing or ampersand, however you draw that on there. Now I've never actually done it this way. Something like that. It might go right here, but basically using the dash arrow fulfills this purpose. It references our pointed to item and allows us to directly access the next feature within that item. So I hope this made some sense for you. The reason this is very powerful is because these don't have to be in a row within memory. This could be at 0, this could be at 1,000, this could be at 5, this could be at 1 billion, so on, whatever. these can be all over the place, and these pointers linking between the different nodes allow us to just jump all over computer memory and dynamically create new nodes to our list. And then we can delete them similarly using the delete function, which is a lot like saying new, only you should be familiar with how delete works. So I'm not going to run through that. That would make this a really long video. Last thing though, no throw. You might have been like, what the hell is that all about? No throw is something which forces it not to throw an exception. Because, you know, when you create dynamic memory, your computer might be out of memory. It might not be able to create that. Normally, when you use the new function, C++ will throw an exception if there's no memory. You can force it not to throw, and then you can run a test on new node, and it's just like a boolean, if new node. And actually, in this case, you'd probably want to say if not new node, then you can do whatever you want to exit your program gracefully. That's why I'm a fan of no throw, because instead of just the program crashing and creating in some exception window that the user has no idea what happened, you can create your own error display statements for your user. So I know that one was a little difficult. I hope we've explained it somewhat well for you. The main thing to remember is these 3 steps. Create a new node, set your first node, use that to set the value of the next within the new node, and then set first node equal to your new node. So you're continually setting next equal to whatever is being created, and you're continually moving your first node pointer back through the node. I hope this has been helpful. If you have questions, I didn't really know how to tackle this one in a very simple manner. But if you do have questions, post them in the comments section. Maybe I'll create new videos, or maybe I'll answer it there. Thanks for watching.